Are you looking for high-performance microcontrollers with unmatched integrated security for your next intelligent IoT and embedded product? Look no further than the Renesas RA6 microcontroller series. Greetings, I'm Ashish Ahuja at Renesas Electronics. In this video, I'll show you the innovation kits for the RA6 microcontroller series. Using these innovation kits, you can quickly and easily develop proof of concepts for many applications such as industrial, home, and office automation, network communication, and grid infrastructure that require comprehensive security and extensive connectivity interfaces. We'll talk about the key features of the RA6 series kits, unbox the flagship kit EK-RA6M5, and run the quick start example application that it comes pre-programmed with. So let's open the box and look at what's inside. To help you get started effortlessly, the kits come with a welcome card that has useful links to get information and technical support, a microcontroller board with pre-mounted pin headers and programmed quick start example project, required accessories. These kits are part of a product lineup that provides an unparalleled combination of standardization and flexibility that helps you shorten the learning curve, speed up development, allow time for differentiated innovation, or to take your end products to market faster. The boards consist of two sections. The first section consists of the ecosystem and system control area that features onboard debugging, ecosystem expansion, serial connectivity, power regulation, user IOs, reset, board configuration. This section is standard on all the boards based on this architecture. The second section is unique to each kit. It comprises the special feature access and native MCU pin access areas. Depending on the kit, the special feature access area could consist of Ethernet, OctoSPI flash, QuadSPI flash, USB high-speed, and CAN with flexible data rate. The MCU native pin access area provides direct access to the RA microcontroller terminals via male pin headers and clamping loops for current measurement. Now, we will run the quick start example project that showcases a mini web server, DNS lookup, USB CDC and MSC, cryptography, and external memory speed comparison. This can serve as an excellent starting point for you to create advanced applications later on. First, please reconfigure the USB high-speed jumper settings as shown on the screen. Please be sure to keep the USB full-speed jumpers in the factory default configuration. Use the provided micro USB cable to connect the kit to the USB port of the host PC. The white power LED will light up and the blue user LED will flash, indicating that the quick start example project is executing. The board uses USB CDC to communicate with the host PC. Open the terminal emulator application such as Terraterm and connect to the serial port the board is connected to. The welcome screen will appear showing various menu options. Press 1 to explore the first menu option. It shows kit information including the microcontroller unique ID, die temperature, and blue user LED's intensity and frequency. Press the blue user buttons S1 and S2 on the board and view these parameters change on the terminal window. Menu options 2 and 3 demonstrate the Ethernet connectivity. We will run a simple web server that allows a platform-independent user interface for remote control and monitoring. Select the second menu option now. Plug in the Ethernet cable connected to a network router to the RJ45 port on the board. Make sure that the board and the PC are connected to the same local network. Press Tab to initiate the connection with the IP network. The board will be assigned an IP address using DHCP running on the router. Open the web browser on the PC, type the IP address in the address bar, and load the client web page. Some of the kit information that you previously viewed on the terminal is now shown on the display console. This demonstrates the communication from the web server to the client. Toggle the software user buttons S1 and S2 in the control panel on the web page to change the frequency and intensity of the blue LED on the board. This demonstrates the communication from the client to the web server. If your router is connected to the internet, you can use the menu option 3 to perform a DNS lookup and find the IP address of renesas.com. The kit pings the IP address to confirm the connectivity with the web service over the internet. Now, let's take a look at menu option 5 that touches upon security and USB high-speed connectivity. We will create a plain text file on a flash drive, then encrypt and decrypt it using AES 256. The EK-RA6M5 board is connected to the host computer over the USB full speed interface, communicating with the PC using the communications device class. The flash drive will be connected as a device to the board that is configured as a host over the USB high-speed interface, communicating with the board using the mass storage class. Press 5 on the main menu screen. Let's connect the flash drive to another USB port of the host computer. Format the flash drive with FAT32 file system. Create a text file, name it as source.txt, enter plain text in it, and then save it. Eject the flash drive from the computer and connect it to the USB high-speed port of the board using the USB host cable provided in the kit. Since USB supports hot swapping, there is no need to power off the board. Press Tab to continue. The microcontroller will read the plain text file from the flash drive, encrypt the contents, and save the ciphertext in a new file. It will then decrypt the ciphertext and save the decrypted text in another file. The plain text and the decrypted text will be compared to indicate successful execution of the cryptographic operation. Remove the flash drive from the board and connect it to the host computer to examine the files. As you can see here, the contents of the source and decrypted files match. Here is the encrypted text. Please feel free to explore the remaining menu options. The innovation kits also feature multiple debugging modes that allow you to debug the RA microcontroller on the kit or on your custom board. The kits are also compatible with popular ecosystems. The expansion ports allow you to conveniently enhance the functionality of the kits by simultaneously connecting several third-party add-ons. You may also connect a general-purpose prototyping board to implement custom functionality, enabling you to quickly put together various sophisticated real-world end applications. For more information and to order your own kits, please visit the kit web pages. This is where you can download the Quick Start Guide, user manual, example project bundle, schematics, bill of materials, design files, manufacturing files, drivers, middleware, and development tools. So in this video, we talked about the key features of the RA6 series kits, ran the quick start example on the flagship kit EK-RA6M5, and learned how you can utilize these to quickly develop differentiated and smart IoT products and applications. I invite you to join the Renesas community on the RA support forum. This is where you can ask questions, get assistance from our team of experts, and also collaborate with other members of the Renesas community. We hope that you enjoy innovating with these kits as much as we have enjoyed developing them. Order your favorite kit today and bring your big ideas to life.